First of all, I'd like to thank everybody for having me on as a presenter. I'm very honored to be part of this organization and be part of the festivities we've planned over the next couple of days. The subject with which I'm dealing is basically living with landslides in the Pittsburgh area. As geotechnical, geologists, we are challenged and also graced with some very interesting soil and rock conditions in the area. And as you can see from the slide that is appearing in front of you, over 200 years ago, the Native Americans who roamed the hills and valleys of our great state of Pennsylvania were first attuned to the fact that there's something different about the banks of along the river, the Monongahela. And that's how they basically christened it in the Unami language, which is an Algonquin language, as a river that has falling banks. Certainly in the most recent histories of landslides in the area, you can certainly see why that is fortunately named. We have, for a significant amount of time, dealt with some extremely steep environments to play with. Building on the hills around the main area of Pittsburgh has been an exciting and very challenging opportunity for many engineers. The two slides you see here, the one on the left is the Bigelow Boulevard, which approaches the city from the basically downtown Oakland on the bluff above the Allegheny River, and on the right-hand side you see Heron Hill. And what's shown on Heron Hill is actually a scarp from a landslide or a mass wasting of material that was just perched there for a long time. It had not been disturbed, but it was a naturally occurring thing. And unfortunately, the street down below where the houses are had been cleaned off so many times in the past that they finally decided to do something. And for both of these entities, they built some massive concrete retaining walls. Back in 1954, Dr. Ackenheil was actually working on a landslide in Bigelow Boulevard that involved the gentleman who was responsible for the excavation of the Panama Canal. And in that gentleman's version, he said, just let it go and slide. You're not going to be able to do much to stabilize the hillside, so just let it go. And that's what they did. Now what we have today holding that situation up are some massive concrete retaining walls, and they've probably displaced some of the buildings you've actually seen here. Most recently, we've had landslides on Beechwood Boulevard, which is overlooking the old steelworks down along the Monongahela River. We also have landslides at the west end along Carson Street that I believe Dr. Hamill has presented many times in his talks about landslides in the Pittsburgh area. Again, these are incidences of modern occurrences that are still following the same conditions and characteristics associated with the landslide susceptible soils first recognized by the Native Americans who occupied our area. Again, this is another version of the West End slide near the West End Bridge. You notice the house in the background. It went for a nice long ride down slope as the materials suffering from heavy rainfalls early in the springtime decided to carry themselves down slope. We also have Streets Run Road, which is a road that cuts right through one of the stream valleys that cuts through the hills of Pennsylvania. It's a very common occurrence where the shoulder of the road gives way and slides down, taking part of the pavement with it. The ubiquitous orange cones from PennDOT are isolating the area to keep traffic away from it. But again, these features are well established in and around the Pittsburgh area. If you do any driving, which I'm sure most of us do, you've run across situations where alligator cracking and tension cracking in a roadway precipitates soil movement, and over time you'll find out that PennDOT does a very good job rectifying these situations that occur. Why is this the case? Well, this map presents some of the most notorious, I guess, areas of landslide susceptibility across the United States. And if you read the dark red section straggles up into the Pittsburgh area, you'll see it follows the Ohio River. Why is it so prevalent here? Well, we are in the midst of the folded mountains of the Allegheny Range. In their folding, they have brought to the surface or slightly below the surface various layers of soils, especially those deposited over a long time that were at the bottom of lakes, at the bottom of old oceans. They are silty, they are clayey, and unfortunately, they are very susceptible to weathering. And as a result, they appear on the sides of hills having been cut by streams, and the more exposure they have and the longer they stay in the atmosphere, the less they lose strength considerably over time. There is a test that engineers perform called slaking, where you alternately wet and abrade materials in a controlled environment, and you notice how well they break down. These materials, when wetted and then abraded, fall apart very, very easily. And these are the things that are now supporting some of the roadways and are situated on the hillsides that surround Pittsburgh. The map extends significantly through Pennsylvania down into West Virginia, Maryland, which is interesting. On the west side of Pennsylvania, we have landslide susceptible soils. On the eastern side of Pennsylvania, we have pinnacled limestone karstlands, which in and of themselves is another geologic hazard that engineers have to deal with. What type of slope movements are there? Well, there's a slump rotational slide, there's an earth flow, there's a mud flow, a debris avalanche, and a rock fall. I will talk about each one of these in a little more detail as we progress through the presentation. But in essence, what it is you have found a plane of weakness within the structure of the soils and rock that are situated on a hillside, either by overloading with rainfall or actually placed materials or cutting into the toe of the slope where man interfaces with the individual soil materials. You can actually precipitate each one of these landslides very easily. This is a very common occurrence in and around Pittsburgh and also western Pennsylvania. Because of the way the materials are layered, at different interfaces you will have outcrops that where perch water percolates through, and you end up having a swampy area or a extremely wet area perched on a hillside. Then below it you have materials that are not quite as strong, so it gains water weight out over time, and it just starts creeping. And as it creeps farther, it gains momentum, and that momentum turns it into a larger landslide. The hummocky ridges that you see at the bottom of the slide are very typical of ground that is susceptible or has moved in the past. Indications of movement are also seen in physical things that are placed on the hillside, like telephone poles. You can also tell the ground is moving by the shape and the orientation of trees. If a foundation or a structure happens to be built in an area where sliding occurs, you'll see cracks and displacements laterally and vertically within that structure as well. It's also, you'll find areas where, at least in my experience, significant wild grapevines grow because they love water, and water is associated with some of the red bed areas that we have in the Pittsburgh area. Typical slough or a slump. Not only do these occur in natural materials, but they can occur in man-made embankments as well. They're quite common to see along highway cuts and highway fills where areas of seepage occur, and they can actually seep into those soils that have not been significantly compacted or compacted to specification, allowing for a larger void ratio and water creeping in. They gain weight and then just slump over time because there's not enough internal strength to keep them in place. One of the ways that PennDOT and other Department of Transportations have handled areas such as this is removing those soils and then filling the area with large diameter rock, which has a higher internal friction angle, and is also open graded so it can weep water out. It's collected in a trench drain below it or in an inlet and then pumped on out of the system. Mudslides are a combination of soil and a lot more water. It becomes extremely dangerous in areas where there are very steep valleys and little soil or, little grass or tree cover to protect and keep the soil in place. These are more associated with areas on the West Coast in California. Actually, this slide is on Route 50 out near Sacramento, California, where they had a previous forest fire. It denuded the hillside, left the soils exposed. Heavy rains occurred over a single night, saturated the material, and the material became more water than it was particles and slid down the hillside. A typical landslide has the characteristics identified on this slide. There is always a main scarp or a zone where the material has left its natural setting, and it basically is the maximum point of sliding. I mean, that's where you see the greatest separation between the existing ground surface and the top or the head of the slide. Precipitating this, you may see tension cracks in the ground, which allow water to infiltrate and accelerate the sliding by lubricating the actual failure plane and allowing water to inundate the soil mass itself, making it heavier. The other areas are, again, identified as minor scarps, which happen as a small slide within the actual slide, and then there are different hummocky areas that are down at the toe of the slope, and the overall displacement could be measured from the crown down to the toe, and basically the volume that is occupied could probably be delineated through survey and material computations. So that's the way that they actually determined how some of the materials for this landslide occurred in 2006 and in Killbuck Township. This slide was actually a combination of man placing fill on natural soils that had very low shear friction angles. I actually spent some time on this site putting in inclinometers and taking soil sample tests from the actual after the slide. We determined that, like most of the red bed soils that become colluvial in nature after they've migrated down slope, had a shear friction angle of about 14 degrees, which is a slope somewhere on the order of 4 to 1 being stable. In this application, they were trying to build a 2 to 1 embankment slope on top of this materials in that area. There were other factors that contributed to the slide. They did some blasting on the day before it happened. There were significant rainfalls in the couple weeks preceding the blasting, but in all, for most purposes, the placement of the heavy fill on top of a very weak soil precipitated the landslide, which basically inundated the railroad tracks at the base, covered over Route 65, and displaced approximately 500,000 cubic yards of material in time. This is a picture of the West End slide, where you see the scarp at the very top of the page, above the light pole to the left, and the hummocky and displaced mass wasting material coming down the hillside. Again, primarily precipitated by oversaturation of the soils, making them heavier and exceeding the shear friction angle they have to resist movement. You'll notice that there is a significant reddish tone to the material. It can be associated with a marker bed in the Pittsburgh area known to have very low shear characteristics, known as the Pittsburgh red beds. There are other clay stones in the area that have similar properties, but they aren't as thick and they aren't as prevalent. When we do geotechnical investigations around the area, we typically can tell where we are in the geologic structure by the occurrence or the location of the top and the bottom of the red bed layers that we are dealing with. This is a picture of the Route 30 slide that happened, I believe, last year. Again, a situation where you have a fill material that's been placed in an area that may or may not at the time been identified as having landslide susceptible properties. The conditions in that spring before were significant water forming, collecting inside the road bed and the materials underneath. The added weight just exceeded the internal shear strength of the material, and it slid down the hillside. Unfortunately, there were a couple apartment buildings below that suffered damage and had to be demolished, but PennDOT actually did a very, very good job in restoring that and stabilizing the hillside with a combination of large rock supported by a tow retaining wall that consisted of concrete lagging panels and steel beams. This is a picture that taken on Route 28, Freeport Road, so to speak, out near Blawnox, Pennsylvania, a road that I've traveled many times. The road cut itself is into the hillsides that expose fractured rock, sandstone primarily, above a weakened soil layer such as a clay stone. What happens in this application is the clay layer gets eroded away underneath the larger block of rock, progresses back till you reach a vertical joint or a horizontal joint in the rock surface, and because it's lost its foundation material that holds it in place, it typically tumbles down the hillside. There have been a number of programs developed that can actually express in terms of distance and velocity how far out the rocks can fall given the slope conditions from which they came. It's an interesting program to run, and for the most part, the larger the particle, the closer to the actual face of the slope it will fall. Some of the smaller pieces you may be able to see still scattered out towards the cones, but the larger blocks seem to stay well within the zone closer to the face of the slope. And something that other engineers in the mining industry and also specifically in the Colorado area have to deal with, where you have fractured rock and some weakened joints below it that cause the rock to fall. Recently, as a matter of fact, in early 2019, Millville, which is a small area along the Allegheny River in Allegheny County, experienced some significant landslides. To give you an idea of how the city is situated, it is in the valley between very steep hills on either side. The hillsides on either side have been labeled as having landslide susceptible soils, and they are of a significant hazard to the community. This is actually a street above the town. If any of you know where the interchange is with Route 28, it's off to the right-hand side along the Allegheny River. And you'll notice up here that I've tried to capture some of the tension cracks that have shown up and the slope movement that has occurred on the near Logan Street. This is another section at the far end of Logan Street, which is, again, showing the characteristics typical of a landslide that has been occurred within the city. The scarp is there right past the Sawhorse. You see the displaced materials, but what this slide does not present is the fact that the slope travels down another 150 to 200 feet to one of the streets in Millville below, Spring Street. This was again precipitated by significant rainfall and unfortunately drainage paths leading directly to the top of the slope here. This is what happened at the bottom of the slide. The toe of the slide is actually right behind the main part of the house here, and you can tell that it's been significantly shifted off its foundation. These are the kind of characteristics of structures that are in the paths of soils that do move. In this application, the family was removed from the house, and unfortunately we had to condemn the house because it was no longer fit for human habitation. One of the consequences of the landslides that affect property. We are very fortunate, and as you can see in this picture, it's an upstairs bathroom, and the piece of material that is right next to the toilet is actually a limb from one of the trees that crashed through the house. If anybody had been in that bathroom at the time of the incident, they may not have survived. So they're very fortunate in the fact that that's the really the only interior damage that was done other than the shifting of walls and the displacement of materials that occurred.